So another application area for cybersecurity is going to be networking and communications. This in itself is actually a massive area with several sub areas, and I'm going to only talk about a few of them. But you might find this to be something that's really of interest to you. So I want to make sure I cover this one because it has some good stuff behind it. The first part is wireless hacking. So this isn't, again, something we are going to cover extensively. If you've done some of the communications, electronics, and digital transmission theory class, you actually may have run into some of the topics that you'll need to understand wireless hacking. So a popular device is called the Hacker RF1, which is actually a software-defined radio. So I just pulled up an example here. This isn't any particularly chosen one, but it's looking at hacking car key fobs. So car key fobs are a popular target. They're typically not super secure, right? Someone stealing a car is a valid actual threat, and there's people that are working on this type of stuff. But there's a lot more you can do with it, right? Tons of wireless devices are out there. So everything from the pressure sensors in your car often are wireless in the tires, right? So you can look at that data stream, you can spoof it, the MAC pass, bridge pass type stuff. That's a wireless signal that you can learn about with SDR. So there's a huge amount of work you can do with SDR. So SDR, by the way, if you haven't used it before, it's a software-defined radio. You basically have this super flexible receiver transmitter system where you can receive and transmit anything. So what you have is like an analog to digital converter and digital to analog converter, and it's driven by some software that kind of can define what the algorithm is. So it's super flexible because you're not limited to you shall only receive one protocol or this protocol or something like that. Why it's interesting, right, is that if you have non-standard devices, where you wouldn't usually be able to buy a transmitter, or you're not allowed to buy a transmitter, or whatever reason it is, you don't have access to the level of detail you need, a software-defined radio lets you do anything. So a cool example of that is you can actually build your own GSM base station. This has some, if you were to try this as a reference, by the way, you should make sure you do it in an area, so you can do this in like an anechoic chamber or stuff, because there's actually restrictions on being able to transmit in the cellular frequencies, and there's pretty serious fines for violating it. But yeah, so an SDR basically allows you to talk non-standard protocols. So one example is this is a rogue base station, right? So when your cell phone is connecting to a base station, this base station's cellular companies have installed. Well, what if someone sets one up, right? Your phone can connect to it, especially for earlier generation stuff. Security wasn't strongly considered, so it wasn't sort of planned that someone would have these rogue base stations there, right? As we roll out encryption and newer standards, this changes how likely this is to happen. But the point is there's still quite a few old devices out there and devices that will use these sort of protocols. This is something that's actually existed. So this is the base station one's a good example because it's something that's existed in like the police and FBI, and basically allowed entities have had access to base station spoofing for quite some time. So there's a device called Stingray, and this does a bunch of stuff, including base station spoofing. So it can be used to detect, for example, if there was a protest and the government didn't like this protest, they could use this device to figure out who was in the area, because you can track, even without having, so you could say like, well, the government can request from the cellular operators, right, logs, but they could in fact set up their own fake base station and don't even have to tell the cellular operator. So it's a whole different level of transparency that there's potentially no record of, right? So, and this device can do a whole bunch of stuff that you couldn't do just with regular warrants on a base station, right? But the point is those devices exist. So part of the interest in research in it is understanding, if you want to have countermeasures to the devices, if you want to detect when they're in use, you have to understand how they work. And that's where a lot of this SDR research has come from. Another interesting area, and this is like its own whole subfield of wireless hacking stuff, is radio frequency radio frequency ID, RFID tags. So you might not have heard of RFID before, or maybe you have, but these are in tons of stuff. So if you have one of these, touch and go credit card, that's an RFID. If you have an access badge where you touch it to a reader, that's RFID. There's a number of different standards within these, but you almost certainly use RFID already. In your car key fob, there's normally an RFID transmitter, at minimum as part of an immobilizer, and there may be more complicated ones now if you have keyless entry or stuff like that. There's all sorts of different wireless technologies. But normally it's all based on something like that. If you want to get started, so the kind of like de facto get started with the RFID thing is right now the Proxmark 3. There's newer devices coming out too. But this is basically a device that lets you talk to all sorts of different RFID tags that run on different frequencies. So this is an example where there's some different tags and some different cards and stuff like that. And so you can do really basic stuff like clone some of them. So sometimes the tags are just like a serial number written to it, so you can actually clone that serial number. You can do really advanced stuff too. So this is like a real attack. So this is again showing like, if you were to do this, and it's not just, run the demo, what could it look like? So this was some research where one of the Tesla key fobs is able to be cloned. It's not a basic just clone the serial number or something like that. So what you basically have is there's some flaws in the cryptographic protocol that were found that meant if you could interrogate the device, you could perform a relatively quick calculation to actually figure out what the key is. And it used there's this hard drive here because it's actually using pre-computated tables that get called rainbow tables typically. But you basically have some huge pre-computated tables that help you derive what the key is. Once you have that, you could then basically clone it and steal a car. So there's a video. So this is the paper. If you also look up the name of it, you'll probably find the video where it actually shows them going up, cloning the car and stuff like that. So this is a pretty cool attack, and it shows you what is possible as you dig deeper and deeper into this. Okay, so when I said this, this topic is going to be massive. I say that because there's part 2 of it is attacking network equipment. So we talked about wireless. What are the infrastructure that makes our networks go? These are basically or not even small computers anymore, large computers, some of them, but they're embedded computers too. So this is like a stack of various Cisco gear, right? So this networking gear would be in data centers, like it's at Dell as part of their network centers. It's everywhere. There's been a number of attacks on it. One of the most recent ones is that three angry cats attack, and basically it showed how you were able to rewrite firmware on a huge range of these servers and switches and different devices because they did not use a correct sort of secure root of trust when the system was designed. So this is interesting. Part of it is similar to standard sort of, network security type attacks. But this is interesting because the network equipment, right, is not normally just a standard computer. There's normally some other stuff in there, and that other stuff is often closer to the embedded systems that we've talked about, whether it's part of a security subsystem, whether it's part of, some special work that the device does. But a lot of that's actually going to be closer to the embedded computer stuff I talked about previously. Some of it, quickly overlaps with regular cybersecurity. The wireless and SDR hacking. So if you're interested in this, right, basically you can look at different areas. The wireless and SDR hacking. So this is kind of the keyword you probably want. Is SDR hacking to look some of this up. It's itself a massive subfield. RFID hacking would be the other keyword you want if you're interested in that. And it has a ton of resources available too. So none of these we're actually going to go into extensively in the course. I kind of bring them up because it might be an area of cybersecurity that you're really interested in. And it's something that, there's resources out there. And if you don't find them, let me know. And I can post some additional information available for people on this area.